Hello everyone, this is Mrs. Snook doing section 7.6, the inverse of a square matrix. And our objectives today are to verify that two matrices are inverses of each other and to use Gauss-Jordan elimination to find inverses of matrix. And we're also going to use calculator. There's a formula that we can use to easily find the inverses of 2 by 2 matrices, so we'll do that. And then we're going to use the inverse to solve a system of linear equations. So here we go. Our first problem is just showing that matrix A and matrix B are inverses of each other. So when two matrices are inverses, I can multiply them together. So if I take matrix A and I multiply that with matrix B, I should get what's called the identity matrix, or I. Now, when I multiply these together, remember that A is a 2 by 2, and B is 2 by 2. So when I multiply them, my answer should also be a 2 by 2. So the identity matrix I want is a 2 by 2. It's going to look like this. I have ones down the main diagonal, and all the other places are zeros. So that's the identity matrix I'm looking for. If I get that, then A and B are inverses. So let's go ahead and multiply and see what happens. So here's matrix A, 1, 2, 1, 1. I want to multiply that by matrix B, negative 1, 2, 1, negative 1. And we'll see what we get. All right, so for multiplying a matrix, keep in mind I'm going to do row 1 times column 1. And when I do this, 1 times negative 1 is negative 1, plus 2 times 1 is 2, so negative 1 plus 2 is 1. And now I'm going to go to my second column. So multiply first row times second column. And I'm going to get 2 times 2 is, 1 times 2 is 2. And then I'm going to add to that 2 times negative 1 is negative 2. So that's going to give me a 0. And then I'm going to do the same thing now. I'm going to do second row times first column. So second row times my first column. This is a lot of fun. Every time I write something, my computer erases it, so then I have to keep putting it back in there. All right, so 1 times 2 is 2, and then we have a 1 times negative 1, so 2 minus negative 1 is 1. And I did second row, second column, so that's going to put the answer right here. Let's go back and get the first column. So I'm going to multiply 1 times negative 1 is negative 1, and then I'm going to add to that 1 times 1 is 1. So I get a 0 there. So that's the identity matrix. So that means A and B are inverses. All right, the next thing we're going to do is we're going to find the inverse of A. And we're going to do this two ways. The first way is going to be by hand, and the second way is on the calculator. So by hand, what we're going to do is we're going to set up a matrix, and it's going to be matrix A, and then I'm going to put in this little dashed line, and I'm going to put the identity matrix in. So 1, 0, 0, 1. So here's the matrix I'm going to use. And what I want to do is use elementary row operations to convert matrix A, which is this one on the left side. So I want to convert over here. I want to make it look like the identity matrix. And then when I'm done, whatever is over here in this green side, that's going to be my inverse. So let's get started. The first thing I want to do is I want to have a 0 in my second row, first column. So I'm going to go through this column by column. So I'm going to take row 1. I'm going to add that to row 2. So I'm going to right here. I'm going to keep row 1 the way it is. And then my row 2 is going to be row 1 plus row 2. So row 1 plus row 2. That's what's going in here. So when I add row 1 and row 2 together, here's row 1 is 1, 4, 1, 0. Here's row 2, -1, -3, 0, 1. Just add those together. I'm going to get a 0. I'm going to get a 1, and a 1. That's lucky for me because now I have these 3 things that are all perfect. I want a 1 there, I have it. I want a 0 there, I have it. I want a 1 there, I have it. So now all I have to do is take care of that 4. I want to make that 4 into a 0. So what I'm going to do is, as soon as I find what I'm looking for, I'm going to take row 2, I'm going to multiply that by a -4 so that I can do a 4 minus 4, and that will make that 4 that I have in row 1, it'll make it go away. So let's go ahead and do that. So I'm going to write this matrix. And row 1 is the one I'm going to change. So 0, 1, 1, 1. That stays in row 2. But now row 1, and I'm going to subtract 4 row 2. That's what's going in there. So here's row 1, 1, 4, 1, 0. Here's 4 times row 2, -4 times row 2, 0, -4, -4, -4. Add those together, I get a 1, 0, -3, -4. So 1, 0, -3, -4. So now check it out. I have my identity matrix right here. That's identity. That's what I wanted. And then right here, that's my inverse. So my answer is going to be -3, -4, 1, 1. Now on the calculator, what you're going to do is you're going to enter your original matrix on the calculator. So enter matrix A, and I would go ahead and put it in spot A. So go into matrix, go to edit, select A, and make sure that that is a 2 by 2. So 2, enter. 2, enter. Then I'm going to enter in 1, 4, -1, 3. So 1, 4, -1, -3. Now I'm going to go out of my matrix. So I'm just going to say second quit. I'm back into my normal calculator part. I'm going to put in matrix A. So second matrix. I'm going to enter matrix A. And then I'm going to hit the inverse button. That's the one that looks like x to the -1. So I hit that button, enter, and I have my -3, -4, 1, 1. Okay, now what if I ask you to invert a 3 by 3 matrix? I could do lots of row operations, or I can use my calculator. And for 3 by 3 and up, I'm going to say use your calculator. So on your calculators, enter this matrix. So I'm going to go back into matrix. I'm going to go to edit. I'm going to go ahead and change matrix A. And this time make it a 3 by 3. And on your screen, you should see 3 rows and 3 columns ready for your numbers. Put in a 1, and then a -1, and then a 0. Put in 1, 0, -1. Put in 6, -2, -3. Now invert that one. So on your calculator, you're going to call up matrix A and then hit that inverse button, and we'll see what we get. So second matrix. So I'm going to get matrix A, and I'm going to hit my inverse button. And when I invert it, this is what I got. -2, -3, 1, -3, -3, 1, and then -2, -4, 1. So that's your inverse of matrix A. All right, the next thing we're going to do, which is kind of neat, is there's a way to use a formula to invert a matrix. So we're going to use formula. I'm going to show you 2 different ways. The first thing is that you have to look at the elements in your matrix. So when I look at my first matrix, I have 3, -1, -2, and then +2. We have to decide if a matrix can be inverted. And what you're going to do is you're going to take the ones on your main diagonal, in this case 3 and 2, multiply those together. And now I'm going to take the ones on the other diagonal, I'm going to highlight those in green. I'm going to multiply those together as well. So I have a -2 and a -1. And then I'm going to put a negative between both of those expressions, so that I end up 3 times 2 is 6, minus -2 times -1 is a +2. That equals 4. So because when I did this operation, I did not get a 0, this is possible to invert. So this one we can invert. So now the question is, how do you invert it using the formula? So I'm going to put in a matrix. And then what you're going to do, the ones that I highlighted in yellow, those are the ones on the main diagonal. They're going to trade places. So I'm going to have the 2 here and a 3 there. They've traded places. And then the ones on the other diagonal that are in green, they stay where they are, but you're going to change their signs. So a -2 becomes +2, and then a -1 becomes +1. And then what I'm going to do with this 4 is I'm going to multiply everything in that matrix by that 1/4. So now my inverted matrix will look like this. It's going to look like 2/4, 1/4, 2/4, 3/4. Now those 2/4s, I can always reduce those to 1/2. So 1/2 over 1/2. And that's our inverse. Okay. The other one, let's look at this one. So again, on the main diagonal, I'm going to highlight that in yellow. And then the other one, I'm going to highlight in green. And the first thing I'm going to figure out is, can I even invert this matrix? So I'm going to take the yellow, the 3 times the 2, and I have a -6 times -1, that's the other diagonal, put a subtraction between both of those, and I get a 6 minus a 6. That equals 0, so you cannot inverse this. If you get a 0 when you do that multiplication, you can't invert it. The next one, and the whole point of learning matrices, is a way to solve a system. And this time we're going to do a 3 by 3. We've got 3 equations and 3 variables. And the idea is I'm going to have a 3 by 3 matrix, which is matrix A. So matrix A is going to be a 3 by 3 matrix. I'm going to invert matrix A. Okay, so the equations in here, these ones in the middle, those are all going to go into matrix A. And we're going to invert those. We're then going to have another matrix for our variables, x, y, and z. And then we're going to have a matrix on the other side. So this is going to be an equation, and it's going to be -1, 1, and 2. Let's go ahead and write these matrices. Here's matrix A. And in my first column is going to be all x's. The y's will be in the second column, and the z's will be in the third column. So I have 2, 3, 1, and I'm just putting down the coefficients. And then for row 2 is 3, 3, and 1. And then row 3 is 2, 4, and 1. This is matrix A. Now I need a matrix for my variables, x, y, and z. And that's going to equal 1, 1, -2. Then what happens is I'm going to call our first matrix matrix A. We're going to call this one looking for our variables, matrix X. And then this one, which is what each equation equals, that's matrix B. So imagine if you're just solving an equation and I said A times X equals B, and I asked you solve for X. Well, you would just invert whatever that operation is that's happening with A and X. In this case, it's matrices. So when I invert, I need to invert A. So I'm going to invert A on this side, and I'm going to invert A on this side. Then what happens is over here, I just have X. So my X matrix is going to be the inverse of A times the B. So now what I'm going to do is I'm going to use my calculator. I'm going to invert matrix A. I'm going to multiply that by matrix B. And the answer that I get is going to be the answer to my system of equations. So I'm going to go ahead into my calculator. I'm going to go into the matrix area. I'm going to go over to edit. I'm going to make sure A is a 3 by 3. And I'm going to enter in matrix A. So 2, 3, 1. Next row, 3, 3, 1. Next row is 2, 4, 1. Make sure you've entered it correctly. Okay, so that's matrix A. Now I'm going to put in matrix B. I'm going to go into the matrix area. Edit. This time I'm going for matrix B. Matrix B, I want that to be 1 column and 3 rows, so it's going to be a 3 by 1. And I'm going to enter in my answer matrix. Make sure you've copied that all correctly. I just realized I had a mistake there. So I should have -1 in row 1, and then row 2 is 1, and row 3 is -2. Now what I'm going to do is literally on the calculator, I'm going to take matrix A. I'm going to tell the calculator to invert it, and then I'm going to multiply that by matrix B. And you can do that all in one step. So I'm going to get out of the matrices. I'm going to put in matrix A. I'm going to hit my invert button. That's the x to the -1 button. Then I'm going to multiply that, and I'm going to put in matrix B. And when I do that, here's what I got. So matrix X is going to equal 2, -1, -2. So what this means is variable x equals 2, because that's the one on top. X goes on top. Variable y is -1, and variable z is -2. All right, that's it for today's video, everybody. Thank you for watching and have a great day.